So welcome to our Linear Algebra online course for this semester. In order to get started, let me talk you through just the main sort of activities that you're going to do to participate and to learn in our online learning environment this semester. The first thing I'm going to be asking you to do is to introduce yourself. And to do that, and we're going to do this kind of at the beginning of each of our main portfolios of the semester, we're going to have a different set of introductory questions. You're going to contribute a short, no more than 90-second video of yourself at the Flipgrid service. Flipgrid, you can find the link right here on our Getting Started page in the course website. You can also find it when we have a Flipgrid assignment. It'll show up in the week-to-week play-by-play. But if you click on Flipgrid, you can pretty much jump right in. You're going to sign up for an account briefly. I don't even know if you really need to do that, honestly, because there'll always be a link in the week-to-week whenever we have one of these Flipgrid assignments that will take you directly to what we call our Flipgrid board for that question. So here it is. You'll have a short description of what it is I'm asking you to talk about in your video, and then click on the big green plus in order to record your video. You can do this with a laptop, you can do this with a mobile device or a phone, anything that has audio-video capability. So we're going to have one of those brief video chat assignments kind of roughly every other week or so throughout the semester. The second element is something that may be the most important part of the course, the reading and collaborative discussion. I like to call it the social reading of our textbook material. So we're using primarily this semester a textbook that is a free, online, open educational resource. What that means is that it's a textbook that lives on a website. Well, you can print it out and sort of read it on the static page. What I'd like for you to also do, even if you do that, is to use that online textbook as a site for reading and collaborating and discussing, asking questions, sharing resources with myself and your classmates this semester. So how does that work? Well, the reading and annotation assignments will always be linked in our week-to-week play-by-play under the heading of something called Read and Annotate. And so the links that you'll see here link to sections of our online textbook. So here's section 1.1. And if I were to click on this link, what it's going to take me to is going to take me to that relevant section of the textbook that we'll be reading for that portion of the week. And when you follow one of the links labeled Read and Annotate, you can not only read the relevant section of the online textbook, and it's a pretty nice read. It has a bunch of embedded figures and links to other portions of the textbook. Most sections will have exercises at the end, examples in the middle, and so forth. This one doesn't have exercises at the end. But in a read and annotate assignment, I not only want you to read through and develop your own understanding, but also to identify places where you might have questions, might want input from myself or from other members of the class, or might have had to think a little bit harder and reach outside and find additional resources in order to understand. So when you run across those things, make an annotation. The way that that works is that when you follow the read and annotation link, you'll notice that there's a toolbar up here in the upper right-hand corner of your browser. If you click on the little arrow to open up the toolbar, what you'll see is called a hypothesis overlay. Hypothesis is a web annotation system. So once you've signed up for your free Hypothesis account, and once you've also associated yourself with our classes reading group for the semester called Linear Algebra, you'll have the ability to see what annotations have been added to the page already, and so far there's none, and also the ability to add annotations of your own. So if I run across a place in the text where I say to myself, I don't really understand what's going on, what you'll do is highlight it. 3 possible outcomes. Well, what does that really mean? Highlight it, and this little tooltip will pop up that'll allow you to either highlight, which I don't recommend because all it does is literally just color in the text, or annotate. And when you click annotate, it pops up a little window that allows you to add a comment. What is meant here by 3 possible outcomes? Question mark. Before you hit post on this, though, make sure anytime you add an annotation to one of our textbook sections that you're not posting to the public sphere. If you post to the public sphere, that means anybody out in the whole universe that looks at this page through the Hypothesis portal will be able to see your comments. I'd like for our comments to be just our own. So before you post, change the sharing setting so that instead of posting to public, you're going to post to the annotation group called Linear Algebra, which naturally lives under here in the drop-down up on top under Linear Algebra. I have several other groups because I've used this with other courses. Once you've associated with our course, you'll probably only see public and Linear Algebra. So make sure you've chosen Linear Algebra and that when you click post, it says post to Linear Algebra. This makes sure that your annotations are something that we all can see as part of the group, but that the rest of the world outside can't see necessarily. So this is one great way to begin a conversation. And as you scroll through annotations, you might not have questions of your own, but you might be able to help classmates who have posed their questions to answer theirs. And you can reply. All of these discussions are threaded, and I'll be sort of watching in, moderating. I might occasionally join the conversations as well. The important thing that this does is that after you've completed these reading and annotation assignments, I will come in and produce a lecture video on that material inspired by the discussion questions that you pose here. So if there's a particular part of the material that's sticky for a lot of people, then I can address it in a lecture format. The other exciting thing that our reading and annotation environment inside Hypothesis will allow you to do is to share helpful video resources that you find to help understand course material. So, for example, if I run across a place in the text where the text really isn't doing it for me yet, and I need to find some other resources, I go out to YouTube, and maybe I find a video that just, makes it click for me. Then what you can do is share that video directly in your Hypothesis comment. To do that, just copy the URL, which you can do from the browser window, or you could also use the share button down here inside of YouTube. I'm just going to click to copy. And then back in Hypothesis, in a comment, all you have to do is paste that URL. And it's not going to show up automatically, but after you say, include a comment here about why this was helpful. This helped me because I could see a worked out example, or what have you. Once you click to post, it'll not only show your comment, but it'll also inline that video right inside of the Hypothesis environment. So this is sort of the first place where you and your classmates get exposure to new material by reading, by looking at one another's comments and helping to address one another's questions, and by sharing helpful video resources that you find from outside the scope of our course materials. So great, you had an opportunity to read some new material, to have a discussion, to share some resources with your classmates, and you're eager to actually get in and start solving problems. So you're at what I call the practice and collaborate stage. And that happens in sort of two different ways in our course. The first is by practicing problems in our WebWork online homework environment. And the second is by working on proof portfolio problems. So let's talk about each of those two things one at a time. WebWork is an open source online homework environment. Open source means that you don't have to pay for it like you do for programs like MyMathLab or WebAssign or those that go through commercial publishers. So it's free. And it also means that the problems that have been submitted into WebWork that you can use and that we build homework sets from as instructors are collaboratively designed by professors sort of across the country teaching similar courses. The ways to access WebWork are, first of all, there will be occasionally some links through our course website. But the first time you go in, you have to go in through our Blackboard portal. So log into your Blackboard course, and over here on the left-hand side, there'll be a link that says WebWork. Click on that link, and it'll pop up a place that says Enroll in WebWork First Time Only. You can also use this same link later on to get back into WebWork, but the first time you go in, you have to use this one. That's because clicking on this link enrolls you into the course as a student, and so it associates all the work that you do thereafter with your Bridgewater banner ID, username, and password, and so forth, so that we know that it's you. Afterwards, I'll have links in the course website as well. And in WebWork, what you'll see is a series of homework sets. I can see a bunch of them, but at first you're only going to see these two that are open right now. And clicking into them, you'll be able to work on them problem by problem, answer problems. Some of them are multiple choice, some of them are open response. If you have to type in algebra and so forth as part of your answers, there's a great link for some help resources over on the right-hand side of the WebWork screen. How to use WebWork. There's a great link that my colleague Dr. Flood has put together, some resources for how to enter algebraic answers into WebWork. So this is sort of the primary site of online homework this semester. But as cool as WebWork is, the one thing that it doesn't excel at doing is collecting your sort of written out proofs. And we're going to do a lot of proof-based work in our linear algebra course this semester. So for your proofs, you're going to get a set of problems that you can select from to solve and write out proofs that form what we call your proof portfolio for the semester. So every portfolio that you submit is going to have some subset of worked out proofs in it from you. And I'm going to be asking you to type up those proofs and submit them as PDF files. And the best way to typeset mathematics, and professionals across the field use this, is to use an online system called Overleaf. So Overleaf is a collaborative online typesetting and editing environment. And once you've signed up for an account, what you can do is start a new blank project, which is going to look like this. And as you type in your work, you're going to use a little bit of sort of simple markup codes to actually typeset the mathematics. There'll be a little bit of a learning curve on this, but we'll help you through it, and your typesetting will get better throughout the semester. I'm not going to be sort of scoring you on how pretty your typesetting is, but just to get you the practice in using this typesetting environment and this language to write mathematical ideas is really the goal for using Overleaf. So in the practice and collaborate stage, you're working on computational type problems and answering those in web work, and you're also working on writing up some proofs and conceptual explanations and writing through the Overleaf system online. And now, what is the end result of all of this going to be? Well, finally, for each of the learning standards in our course, you're going to need to what I call certify. And what that's going to involve is submitting a quiz and or possibly an exam that demonstrates that you've reached the learning standards that we've set for you in the course. And quizzes and exams are distributed and collected through our Blackboard system. So here's an example of what it looks like from a previous course in another semester. But in Blackboard, there'll be a file called quizzes, where if you go in, you'll see quizzes, and these will be built out as the semester goes on. And the way you'll complete these is by downloading in PDF format the quiz file itself, and then either printing it out and filling it all out on paper, or if you have a mobile device like an iPad or so forth, and you want to annotate using a PDF app on there, that's fine too. But the idea is you download it, you complete it with all of your worked out writing and everything on the page, and then you re-upload it back to Blackboard in the same location that you found it. Then you'll get my feedback on it, and if there's any work to do to revise it, you'll begin to revise it and so forth. So quizzes, exams, and your portfolios, which we're going to talk about in a separate video, all of those get distributed, collected, and your feedback is received from me via the Blackboard system. And that's pretty much it. Those are the most important tools that you're going to need in order to interact with our course throughout the semester. The one that I didn't get a chance to talk about yet, that I want to finish up with, is an online discussion board platform called Piazza. And my vision for our Piazza use this semester is that I want for this to be a place where you can collaborate with one another around the questions that you're having solving web work problems and the questions that you're having working through your proof portfolio proofs as well. So for Piazza, and there's a link to the Piazza site inside of our week-to-week here, and you can also find it in our Getting Started resources. When you jump into Piazza, you're going to have to sign up the first time you go in. But what you'll see is that it's a question and answer environment. So people that pose a question, their question will be over here on the left, and then you can begin a threaded discussion and contribute to answering those questions over here on the right. The very same markup language that you use inside of Overleaf to write mathematical notation, you can also use that inside of Piazza. So if you do have to write an equation or an algebraic expression or something inside of Piazza, you can do that as well. So Piazza is going to really be a location that I want to reserve for you, your classmates, and our preceptor this semester to really sort of talk through those issues around how do I actually solve the problems that I'm trying to solve in the practice environment. The one thing I don't want you doing through Piazza is discussing quiz problems and discussing exam problems. Those are the one things this semester that really need to be individual to you. Everything else that you work on this semester, I want to be collaborative because I want you interacting with one another and interacting with me as the understanding of linear algebra develops. So that's an introduction to what you can do to get started and the most important tech tools that you'll need to begin to interact with our course. If you have a question about this, drop it into Piazza. Jump into Piazza. I've got a thread here called Questions About Class Structure. If you post your question here, I'll see it. It gets emailed to me as well, and everyone else in the course will be able to see it too, so they may be able to answer your question, even if I might not answer it right away. So please be in contact with questions. I look forward to working with you this semester. Let's learn some linear algebra.